So in this video, what we are going to do is we will set up an EKS cluster in AWS. There will be an EKS cluster, and we will be having a GitLab repository with a very basic CI/CD pipeline, right? And what we will try to do is we will try to run this particular CI/CD jobs in our EKS cluster as a pod, right? So there will be pods, and based on the requirement, the number of jobs that we have in CI/CD pipeline, we will scale up our pods, right? So this is what we are going to see in this video. So if I'll deep dive a bit in Kubernetes in EKS. So in EKS, when we talk about auto scaling, so there are two types of auto scaling, right? One is the pod scaling. So if we have number of pods, let's say if we are running let's say 5 jobs in a CI/CD pipeline, and those 5 jobs are able to spin up on that particular EKS cluster, because that EKS cluster has plenty of EC2 machines behind it, right? So that's fine. But let's suppose our number of jobs gets increased from 5 to 500, right? Then how these jobs will be placed on that EKS cluster? That means we would need to have plenty of EC2 machines or EKS nodes behind that Kubernetes cluster, so that our 500 jobs would be able to scale up, right? So this is how, like, we will see in this video, like how we can scale up that Kubernetes cluster. So for this use case, I'll be using Karpenter here, right? So yeah, so in this video, what we will be doing is, so there are prerequisites for this video, which is an EKS cluster, which I already have provisioned in my AWS account. So I assume you already know how to create an EKS cluster in AWS and how to access that EKS cluster. So I have already done that. I already have a GitLab repository. A blank GitLab repo is there with a very basic CI/CD pipeline at the moment. And yeah, within this EKS cluster, I already have Karpenter deployed, but I am not using this Karpenter at the moment. So yeah, we'll enable the Karpenter later in this video. But yeah, for now we will be deploying the GitLab runners in Kubernetes cluster without Karpenter first, and then we'll see what effect we will be getting if I'll enable Karpenter in that Kubernetes cluster, right? So yeah, let's jump into our AWS console. So I am in my AWS account now, and if you'll see here, I already have one EKS cluster, which is cluster name is Balvinder, and I'll be using this EKS cluster to deploy my GitLab jobs in here, right? So to do that, first we will create a GitLab runner in GitLab, right? Yeah, so let's proceed step by step. So first, let's go to GitLab, and over here, this is a fresh GitLab account that I have created. And if I'll go to groups, I have created one group here. Yeah, this one. And within this group, I have one repository, a blank repository. And there's nothing in this repository, but there would be one CI/CD pipeline file with a very basic CI/CD. It just run 3 jobs, and that's it. So we are going to run these multiple jobs in our EKS cluster, right, as a pod. So we will be deploying GitLab runner as a Kubernetes executor. We will use Kubernetes executor to deploy that GitLab runner. So for that, the first step would be to create a token for that runner, right? So what I'll do is I'll go to CI/CD under the second settings tab, and over here, if I'll go to runners, as you can see, I don't have any custom runner here. These are instance runners which are managed by GitLab. So these are the GitLab managed runners, and we are not going to use this one. So what I'll do is I'll be creating a project runner here, and I'll give it a tag. So let's say I'll give it a Kubernetes tag K8s, and this is the tag that we will be using later in our CI/CD pipeline, so that our jobs would be able to run on this particular GitLab runner, right? So sorry, this needs to be unchecked. And if you want to define any maximum timeout something like that, you can do that, but I'll go with the default 600 seconds, and I'll create the runner. So once we'll create this runner, we will be getting one token. So this needs to be a secret token. I'll remove this token after this video is completed, so you won't be able to access this token. So what I'll do is I'll copy this GitLab runner, and because this needs to be a secure GitLab runner, so this is a secure thing. So what I'll do is I'll create a secret manager in AWS, and I'll store this particular GitLab runner in a secrets manager. So what I'll do is I'll store a new secret. It would be other type. I'll name it as, let's say, GitLab token and its value. And next I'll give it a name, let's say slash GitLab slash cats runner token. So this is the name of this particular secret. I'll save it. No automatic rotation would be needed. Okay, next, store. So yeah, this is one of a good way, best practice, so that we can fetch this particular token from secret manager. I'll show you how it can be done. So my plan is to deploy this GitLab runner in Kubernetes using Helm. So I'll be using Helm in Terraform, right? So using Terraform, I'll fetch this token and then we'll inject this token in our Helm registry using Terraform. I'll show you how it can be done. So yeah, so we have our token. We have got our runner, and we have got the token for that runner authentication token. And so now the next step would be to deploy our Kubernetes executor in our EKS cluster, in our Kubernetes cluster, right? So if I'll go to this page, there's an Helm chart provided by GitLab, and we will be using this particular Helm chart, right? And this Helm chart, we're not going to run any Helm command here. We are going to use Helm as a in a Terraform. So yep, let's see how it can be done. So this is the Helm registry which we will be using, and this is the Helm chart, and we can pass the value.yaml file within this Helm chart. So yeah, let me set up the Terraform code, and let me pause the video here, and I'll show you what Terraform code I'll be using here. Yep. Okay, so I have my Terraform code ready for it. So this is the Terraform code that I'll be using here. So in Terraform, I'll be using Helm release to deploy GitLab runner in our Kubernetes cluster. So this is the Helm repository. This is the chart that we will be using, and this is how I'll be fetching that runner token from secrets manager. I'll be using data source here, and this is how I'll be fetching the token from a particular secret manager in AWS, right? So this is the configuration that I'll be setting here, and while setting up this particular GitLab runner, I have configured the runner config as a Kubernetes executor, which means this particular GitLab runner will be deployed in a Kubernetes cluster, and it would be in namespace GitLab, and the default image would be Alpine Linux, right? So so this would be the default. If for example, while creating our CI/CD pipeline in GitLab, we haven't defined any Docker image, so this is the default which will be picked up by the runner, right? So let's deploy this particular Helm release in our Kubernetes cluster. So for that, what I'll be doing is I'll just run this command terraform apply with the target option here, because there are other Terraform code in my Git repository as well, which I do not want to apply the changes because I have done a couple of manual changes in AWS, and those manual changes will be reverted back. I know this is not a good practice to make any manual changes in AWS if we are using Terraform, but for this particular demo purpose, I have done that. I have made a couple of manual changes in AWS, and I do not want to revert those manual changes, which is related to Karpenter, right? So what I'll do is just to deploy this particular Helm release, I'll use a target option here, and I'll just pass the target as Helm release, RELEAS, Helm release dot GitLab, right? So this particular option will only take care of this particular Helm release deployment, and it will not touch any other resources. So yeah, this says one to add, and this is what our GitLab runner will be deployed in Kubernetes. I'll say yes and enter. Okay, so Helm has been deployed the resources. So this is apply completed. If I'll go to my GitLab page, this is where the runner was created. If I'll do view runners, so our runner should be online. So yeah, here you can see this is our runner, and this is green, which means runner is online, and we can use this particular runner to run our GitLab jobs. I'll get into my GitLab repository. Let me search for it where it is. Yeah, here. I'll go into the code base, and what I'll do is I'll just quickly open a web IDE, and on the same time, let me just put it in on the right side. So this is my terminal, and let me just place this on the left. Yeah. So this is my GitLab YAML file, a very basic CI/CD file. And over here, what I can do is just to run these jobs on my particular GitLab runner, what I can do is I can just define the tags, and the tag that I have defined while creating that GitLab runner, right? So this is the tag that's going to be deployed. So I'll just put a sleep here. Let's say sleep for 600 seconds, and I'll do the same with all of the jobs. So okay, sleep, and here. So this is the changes that I have made. So now all of these 5 jobs should be able to spin up in our Kubernetes cluster. So what I'll do is here, I'll just do a watch command, watch kubectl get pods in GitLab. So what I'll do is I'll just commit and push the changes to the main branch. Yeah, as you can see, we have got our jobs in our Kubernetes cluster. So these are the jobs that are spin up. And because I have put a sleep command here, so these jobs will be there for 600 seconds, and then these jobs will be gone, right? So this is the first step. We have deployed a GitLab runner in our Kubernetes cluster, and this Kubernetes cluster doesn't have any auto scaling at the moment, right? So what will happen if I get a large number of jobs here? Let's say for now there are only 4 jobs, and these 4 jobs requires a very limited number of CPU and memory utilizations. So for now, this is good to be spin up on a very minimum EC2 instance. But let's suppose there are 100 number of jobs. Would this particular EKS cluster would be able to deploy those 100 jobs? For now, it won't be able to. Let me try creating these 100 jobs here. So what I'll do is I'll just copy this CI/CD YAML file. I'll just put it in a cursor, and I'll ask the cursor AI create similar 100 jobs here, right? So it should be able to create those 100 jobs. Now I'll commit and push the changes to main branch again, and I'll open the terminal on the right. Let's see. We should be able to see multiple jobs over here. There are most of the jobs that are in pending state because I have created 100 number of jobs, and these jobs will be executed once the previous job which is in running state will be completed. So yeah, because no auto scaling is there in our Kubernetes cluster. So what I'll do is I'll quickly deploy a Karpenter here, and we'll see how Karpenter behaves if we get this overwhelmed number of jobs in our Kubernetes cluster, right? So I already have Karpenter deployed in my Kubernetes cluster, but I have disabled it. So I'll just quickly enable it, right? So this is the karpenter.tf file which I have used to deploy Karpenter. So this is a AWS provided Terraform module which I'm using to provision all AWS resources like IAM, SQSQ, event bridges, etc. Right, and this is the Helm release that I'm using to deploy Karpenter here. So if I'll go to my Kubernetes cluster, if I'll do kubectl get pods in kube system namespace, there's no pod for Karpenter, but Karpenter is deployed. What I have done is I have just reduced the replicas of that Karpenter deployment to 0 so that Karpenter won't work here. So what I'll do is I'll just get the deployment in my kube system namespace. So if you don't know how Karpenter works, how to deploy Karpenter, I have already created a video for it, and I'll put the link in the description so you can take a look into that. Yeah. So this is the Karpenter deployment, and it has a replica as 0. That's why it's not working. So what I'll do is uh, I'll quickly show you the number of nodes that are available at the moment. So there are 2 number of nodes in this Kubernetes cluster. So what I'll do is I'll just quickly edit this deployment kubectl edit deploy Karpenter in kube system namespace, and I'll search for replicas. So this is 0. I'll put s2 here. So if I'll do watch kubectl get pods in kube system namespace, I could see Karpenter is there, and let's wait for it to be up and running. As soon as this Karpenter will be up and running, we should be able to see number of pods should be available in our Kubernetes cluster, right? And those number of nodes should be available in our Kubernetes cluster, and those nodes will be taken care of the pending jobs that we have. But yeah, because we have Karpenter enabled now, kubectl get pods in kube system, Karpenter is there, yeah, up and running. Now let's put a watch to kubectl get nodes command, and yeah, as you can see, Karpenter has quickly spin up 2 new nodes here, right? And these 2 nodes, so Karpenter will schedule the nodes based on the requirement. So what Karpenter does is it looks for the scheduler events. So the scheduler events, and based on that events, it identifies if there's a requirement of new node, and yeah, based on that, it spins up a new node. Yeah, so now let's wait for these pipelines for these jobs to be spin up. Okay, so most of these jobs are in terminating state without being executed. So what I'll do is I'll just quickly cancel this pipeline and we'll rerun this pipeline with 100 jobs. Yeah, so all of our jobs are terminated now. So what I'll do is I'll just rerun this pipeline again, and this pipeline has 100 number of jobs. And yeah, let's see how it behaves now. And now we have Karpenter enabled, so there shouldn't be any failed job in this pipeline. These are the previous failed jobs. So over here, yep, as we can see, all of our jobs are getting scheduled on our Kubernetes cluster, and over here, as you can see, all of the jobs are in running state, right? Because Karpenter is taking care of each and every job. Karpenter is spinning up the EKS nodes behind the scenes. So Karpenter is intelligent enough, so it can decide like what type of EC2 machine would be needed to run these number of jobs. Yeah, as you can see, there are no pending jobs, and all of the jobs are getting in running state. So this covers our first scenario if we have large number of jobs. So what I'll do is I'll just cancel this pipeline, and we'll look into the other scenario where we have a job with a large number of CPU or memory utilization, right? So what I'll do is I'll go to my GitLab CI/YAML again. I'll open the web IDE here. I'll delete all these jobs, right? I'll just keep 2 jobs now, right? So let's suppose this job 2 is a CPU intensive job, and it needs it would require a 16 core of CPU. Let's say 16 core CPU and 32 GB of memory, right? So what we can do here is we can define a variable, right? So there are predefined variable with Kubernetes executor that we can use here. Okay, so these are the variables that we need to define with our particular job that needs a large number of CPU and memory. But looking into this GitLab documentation, if I take a look here, so looking into this particular paragraph, the value for this variable are restricted to maximum override settings for that resource. So there's a maximum override setting that we need to define with our GitLab runner. So when we spin up our GitLab runner using Terraform, so in that helm YAML file, we would need to define this maximum override variable. So if this maximum override has not been defined, right, so this variable is not used. If I'll do these variables without defining that maximum override, so these variables are not being used, right? So first what I'll have to do is I'll have to define those maximum override in my GitLab configuration. So to do that, what I'll do is I'll go to my helm release. So this is for Karpenter, and this is for GitLab, and over here I'll have to define that maximum override variable here. Okay, so looking at the GitLab documentation, so these are a couple of override variables and the default variables that I have defined in my Helm release for that GitLab runner. So yeah, so these are the default variables which will be assigned to that particular job, right? And these are the override variables. So we have defined a limit, like how much override we can do. So let's say for CPU request, we have allowed a maximum of 60 core of CPU. So not more than CPU request would be allowed, right, in our GitLab job. So let's quickly apply this job in my Kubernetes cluster. So what I'll do is Terraform apply have with the target Helm release, and yeah, it should restart our GitLab runner in our Kubernetes cluster. Let's wait for that. Nice. So our changes has been applied, and yeah, let's quickly jump into our GitLab IDE. So this is our GitLab CIML file, and let's quickly commit our changes. So these are the changes that I'll be pushing. So the CPU request would be 16 core and memory request would be 32 GB. So a machine more than 16 core and 32 GB would be required for this job. So now let's see how Karpenter will spin up that. So I'll commit and push the changes. As you can see over here in my AWS console, there's an instance type which is coming up, which is m5a.4x large, which is really a large, like a 4 times large instance, and that job will be scheduled on that particular node. So if I'll do kubectl get pods in GitLab, I should be able to see, yeah, this is the job which is in running state, and this is another job. I have executed the same job too again. So this is another job which is going to be spin up on another large instance, right? Yeah, so this is it for this video. So in this video, what we have covered is like we have spinned up an EKS cluster, we have a Karpenter in it, and we have seen like how we can scale up our GitLab runners using a combination of Karpenter and EKS cluster, and it will give us a very scalable and reliable solution for our GitLab runners, so that they are always available, they are always ready to pick up the jobs. Doesn't matter what would be the CPU requirement and the memory requirement for the job. Even you would be able to define the GPU allocations, like you would have to create a node pool in Karpenter where you would have to define the GPU instance types and everything, and you would be able to scale, like you would be able to schedule the jobs, the GitLab jobs which have a requirement of GPUs. Yeah, so I think this is quite enough for today, and yeah, this is it. If you have any queries, drop a comment of it. I'll try to resolve those queries.